So we know that the total number of terms is one more than n. Okay? So remember, this is x. Okay, so this is x plus y to the n, correct? And if n is 10, the total number of terms is what? 11. You always get one more term because your first term is going to be k equals 0, and then you're going to go to k equals n. So if I go from 0 to 10, that's actually 11 terms. Okay? So it's always one more. So why does this binomial have a middle term? N is even. Therefore, there will be an odd amount of terms. Resulting in a middle term. The triangle with 3 dots means therefore, just so you know. So what has to be true about a binomial in order for it to expand and have a middle term? What does n have to be? Even. So we want to find that middle term. So if we want to, one of the easier ways I do is if I say, okay, though there's 11 terms, if you can't figure out which one's the middle, you can go term 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, well those are even, cancels off, cancels off, cancels off, cancels off. So I'm looking for term 6. And you can write out all the terms and then cross them off, correct? And get term 6. So remember our formula is tk plus 1 equals n c k x to the n minus k y to the k. So we're looking for term 6. In order to fill it into that formula, I need tk plus 1, correct? So what does my k have to be in order to get term 6? 5. So we know k is 5. It's the only thing that changes every single term. Our x, our y, and our n are always the same, correct? Our x for this one is going to be a, our y is going to be b, and our n is going to be 10. So we're going to get t5 plus 1, which is going to get me term 6. And then we're going to say n, which is 10, ck, which is 5, x is a to the 10 minus 5, and b is y, or y is b to the 5. These exponents will always add up to n, right? Because you're doing 10 minus k. You're just doing k, so you should add it to n. And then we just have to math. So we're going to get term 6 equals 10c5. What's 10c5? Can you find it? Thank you. 252. A5, B5. So the coefficient is really easy to get. It's just the 10c5 if your x and your y both don't have coefficients. So I had just an a and just a b, correct? So that's not going to actually affect my coefficient, the number in front. If it was like 2a and 3b, then I would put the exponent to those numbers and have to bring them to the front, and they would change my coefficient. Like if I had a 2a here and a 3b here, I would have to raise them to that power and then bring them and multiply them up by the 252, and it would totally change my coefficient, right? But your coefficient is just 10c5 if this has a 1 in front and this has a 1 in front, because they're not going to change it. All right? Okay, so that's if they ask for the middle term. Another thing they could ask for is the term with y5. Okay? Well, let's set it up. We know x, we'll always know x, we'll always know y, we'll always know n. We might not know k, but we can always figure it out from information they give us. So let's see what we can do here. This binomial has to have a what in front of it in order to use the binomial theorem? What has to be in the middle? A plus sign, yeah. So if we look here on our formula sheet, it says x plus y to the n. That's the form I can use to do this, right? Just like our quadratic formula up here says it has to be an ax squared plus bx plus c equals 0, and then I can use this. Same thing, binomial theorem says it has to be x plus y to the n. If it's not, you need to make it that way, okay? Often they'll put a minus sign in because you'll use x for 5 and y, you'll use 2y, and you'll get it wrong. They'll have the answer there if you do that, okay? So we know that this binomial is actually 5 plus negative 2y to the 8th. So this is my x, this is my y, this is my n, I don't know k, but they have to give me enough information to find k. So they either have to give me the term number, and then I know it's 1 less, or they have to give me something about the actual thing. In this case, they told me the term has a y5 in it. So we'll deal with that in a second. If we don't know what k is, we can just put k's, or we can put blanks, whatever we want, until we can figure out k. I'm just going to leave a k in it so we can see. So we're going to go tk plus 1, I don't know what k is, equals n, which is 8 ck. The good thing is, once I find out what k is, all the k's are the same. I just fill in that number, right? And then I get x, which is 5 to the 8 minus k. And then y is negative 2y to the k. It tells me that the term has a y5 in it. How do I make that term have a y5? T6, why? It's true. I need to put a 5 in this k, correct? If I put a 5 in this k, I'm going to get y5. Am I not? Does this one have a y in it at all? Or here? No, that's the only thing that has a y. I need it to be y5. So then I say, oh, k has to equal 5. And then I go back and fill in my 5. So I get t 5 plus 1. Now sometimes their question is, what term number contains y5? It would be term 6. I'd be done. I wouldn't even have to figure it out. Does this say term number? No, this says term. So I actually have to figure out the term, the whole term, not just the number. So I'm going to get 8c5, 5 to the 8 minus 5, negative 2y to the 5. So I get term 6 equals, what's 8c5? Skip 6. And then 8 minus 5 is 3, so I get 5 cubed, which is 125. And then the common error happens. Everyone tells me it's negative 2y to the 5. What do I have to remember to do? Yeah.
5 for the negative 2.
Yes. So I have to distribute this 5 into the negative 2 and the y. So I'm going to get negative 2 to the 5 in brackets in my calculator. Because it's to an odd exponent, it will stay negative. But we want to make sure that we have the right sign. So negative 2 to the 5 is negative 32, y5. And then I have to multiply my coefficients, all these numbers. So term 6 equals 56 times 125 times negative 32. 56 times 125 times negative 32. What do we get? Y5? So this is the term. guys will mix this up. That is the term. So if I ask, yeah, sure. If I ask for the term, that is the term, correct? If I ask for the term number, which I didn't, I'm just going to put this in a box so that we know the difference. If I ask for the term number, what would it be? 6. So sometimes they ask for the term number because there's a numeric response box and I can't fit negative 224,000 into it. So they'll ask for the term number instead, which is 6. Okay? Okay, constant term. We're going to star this one because this one is the one that people's brain matter falls out. Everyone just kind of forgets about it. So I'm going to do it like a lot of these. Put your pencils down. We're going to go back to grade 10 for a few seconds. We are in grade 10 a lot. Almost every grade 12 question ends in grade 10 math. So grade 11 math comes up sometimes in quadratics, but grade 10 math comes up all the time. Reducing radicals, collecting like terms, distributing, factoring, exponent laws. That's all grade 10. So grade 10 is very important. I always tell grade 12s, if you know a grade 10 kid, tell them they need to try, because it comes up in grade 12 all the time. So a lot of people are really good at the grade 12 content, and then they get the answer wrong because they can't do grade 10. Okay? So in grade 10, we were taught that if we had like 3x to the negative 6, it would be over 1. Anything's over 1. We agree? And if we wanted to make it a positive exponent, where could we move it? Yeah, we can move it to the denominator. Now, is this 3 to a negative 6? No, this 3 has an exponent. It's a 1, because it doesn't have, like, if it was 3x to the negative 6, that would be different in brackets, but it's not. So I would leave the 3 in the top, in the numerator, and the x to the 6 would move to the denominator to make it positive. We agree? So, could I not do vice versa? If I have the exponent in the bottom, could I not move it to the top and make it negative? Also, if I had like 1 over x to the negative 2, I could move this up and it would be 1x to the 2, right? Like I can move it up and make it positive. So whenever you move an exponent, a variable with an exponent, to the top or the bottom, you're changing whatever sign it has. So if it's negative, it becomes positive. If it's positive, it becomes negative. Nothing crazy. That was a law you were taught in exponent laws in 10C. Okay? I don't care if you remember it, as long as that makes sense to you now. So, when I see this next one, it wants the constant term. The constant term is the term without a variable. Now, this is why. So, if I gave you 2x squared plus 3x plus 4, and I said f of x equals this, and then I put in f of 2, let's say, right? 2 times 2 squared plus 3 times 2 plus 4. This term is changing, correct? It's going to be something different than that one, isn't it? When I plug it in? What about this one? That'll be different. What about this one? It remains constant. No matter what I plug in for x, it's going to remain constant. It's not going to change. So it's called the constant term. The constant term is the one without a variable. So let's go back. So I want the term without a variable. I want the term where the x's go away. The only way that can happen is if you have x's in the top and x's in the bottom. Grade 10 again. If I gave you a to the 7 times a to the 3, my answer would be a to the what? It's not 21. A to the 10. Because we add exponents. We agree? Okay. If I gave you a to the 7 times a to the negative 4, I would get a to the what? 3. Add exponents, right? A to the 0 is what, guys? What's anything to the power of 0? 1. So that would get rid of the variable, correct? Which would make it constant. So if I got a to the 0, the variable would go away and I'd be left with a number and that's constant, correct? So if I gave you a to the 3 times a to the negative 3, I would get a to the what? 0, which is actually 1, and I have a constant, don't I? Okay. So if I gave you a to the 5 times a to the something, and I need it to be a constant, a to the 0, what is this going to have to be? A to the negative 5, is it not? So ultimately, when I want a constant, I want two variables that are the same opposite sign numbers, because then they cancel off, correct? So I want the constant term in this question. So if I want the constant term in that question, I want x to some number, x to the same number minus, like minus that, and then I'll get x to the 0, and then I'll get a constant term, ultimately, right? So let's look at this one. I personally do not like, well, I like dealing with fractions. I personally know that you don't, in general. Most people hear fractions, and they have a little bit of a bleh in their mouths. Okay, so we're going to rewrite this as 2x minus 1. How can I bring this up? We're using grade 10 laws to even start this. X to the negative 2, right? So we're going to get 1 with an x to the negative 2 to the 15. Does everyone agree and see what I did there? Do I need that 1 in front? No, the 1 is irrelevant, but we can keep it. What do I need before I can say x, y, and n? Positive. So I'm going to go 2x plus negative 1 x to the negative 2 to the 15. And because I'm taking a negative sign, I'm going to write it as negative 1 because I want people to remember to distribute to that number in front. When it's a negative sign, people forget. When it's a negative 1, you're like, oh, I have to distribute. So I leave it as negative 1. So this is my x, this is my y, this is my n. Okay? We all agree with what I did there? That makes sense to you? So, let's fill in our formula. What we do not know is k. So if we don't know k, we can leave it as a k. So let's fill it in. So we get, and when I see constant term, guys, I know I'm going to need an x to the 0 in the end. We know that. So I'm just going to leave that sit there to remind myself of that. So I'm going to go t k plus 1 equals n, which is 15, ck, don't know what it is, x, which is 2x, to the 15 minus k, and then y, which is negative 1, x to the negative 2, to the k. So did I do anything crazy? No. Did I just fill it in and leave k's be k's? Yes. So when you're looking for the constant term, you will do a little side math to find out what k is. Why? Because I need to know, off the side here, I need to find something that equals x to the 0. True? Do we agree? I need it to be x to the 0 so the x's go away. So what I'm going to do is I'm going to pull the x's out of the formula, only the x's, to figure out what k needs to be to make it x to the 0. So I'm only taking out the x's. So this 5ck sits here. The 2 is fine. I'm going to take x and raise to the power of 15 minus k. Okay? So I'm going to go x to the 15 minus k needs to multiply by, negative 1 stays, I don't really care, x to the negative 2 times k. Do you see that? I'm just taking the x's out. X to the negative 2 times k. So I'm literally just pulling those x's out, and I need it to be x to the 0. Because that would make it a constant. That would make my x's go away. Do we see what I did here? I just took the x to the 15 minus k, and it's being multiplied by x to the negative 2k, technically. I just pulled the x's out. Do we agree? Did nothing crazy. So I have x to the 15 minus k, technically times x to the negative 2k has to equal x to the 0. Yes? I just put the negative 2k. Now when these have the same base, what do I do with those exponents? We talked about it on the previous page. You add them. So I can put this together as x to the 15 minus 3k. 15 minus k plus a negative 2k is minus 3k. Do we agree? I just put these exponents together by addition. Did I lose anyone? Or are we all there? I try and look at your faces. Get me whether you're lost souls. Did everyone see what I did? 15 minus k plus another negative 2k gets me negative 3k. So that's with like terms. And it has to equal x to the 0. So if this is true, what does k have to be? 5. You see that? So we can either do it in our heads and say k equals 5, or we can say, okay, well, if this is true, then 15 minus 3k must equal what? 0, right? I have to do 15 minus 3k to equal 0, because if this is a true statement, this needs to be something so that I get a 0. And I could solve it out. If you go 15 equals 3k, divide by 3, k equals 5. Reasoning-wise, 15 minus 3 times what gets me 0? Well, I need this to be a 15, so k is going to have to be 5, right? Do we agree by math, like just looking at that, k has to be 5? Because 15 minus 3 times 5 is 0. Yes? So I have to do this side box off to the side to find out what k is. Does it make sense what I did? Yes? All right. So now that I know k is 5, I just plug in a 5. So I do t 5 plus 1. So what is the constant term number? 6. What is the constant term? I got to do some math. Okay? So I'm going to do 15c5 to x, 15 minus 5, negative 1, x to the negative 2 to the 5. So I'm going to get term 6 equals, what's 15c5? What? 3003. You all said it, but at different times. It just sounded like 3. I was like, oh, yes, that number. Okay, and then we have to remember that 15 minus 5 is 10, and I have to raise the 2 to it. Correct? So what is 2 to the 10? 1024. X to the 10. This one you would luck out if you forgot to do the negative 5 to the negative 1, because it would stay negative 1. But they'll often make that exponent be even. So if you forget to distribute the negative 1 to it, you'll get a negative, and the answer will be there. But this one's okay. Negative 1 to the 5 is negative 1. X to the 10. Oops. Negative 1, x to the 10. Negative 10. Oops. What happens with x to the 10 and x to the negative 10? They cancel, correct? Which is what we need, because we want the constant term. So bye-bye. And then we multiply our numbers. So T6 equals, I need a smaller marker, negative, what's 3003 times 1024? Negative what?
3,075,070.
So that is the constant term. And we know we're right in a way because there's no variables, right? Constant terms are just the number. So before we get to example 8, shoot that a little bit different because it gives you the term. I want you guys to do this one. This one. This one. This one. So I want you to do these right now. These we will do on Monday. We're going to finish it up really quick on Monday. Then we move on to transformations. But I want you guys to work on these ones. That's a lie. These ones right now. These will not be in your homework check because anything that starts on Friday goes on to the next Friday's homework check. So everything up to Thursday goes up to here. So I'll type those ones in. I just didn't put the assignment in. So these ones wouldn't count. But these ones are on it, right? Because they were from yesterday.